The Entity Framework is part of the ADO.NET family of technologies. And the Entity Framework's goal is to bridge the gap between object programming and traditional database programming. Now, in that regard, it's similar to LINQ to SQL, but the Entity Framework takes us in a number of new and interesting directions. The key to the Entity Framework is the Entity Data Model. And in this model, entities represent your domain objects. Entities are related, and they're related through associations. And stored procedures or user-defined functions are functions within the model. The Entity Data Model is an abstract conceptual model of data. And a key thing to know about it is that it's not tightly bound to a data source or an application. Now, what does this mean? It means that the Entity Data Model is independent of your application, and it's also independent of the data source. One of the key features of it is that entities don't have to be mapped to a single table or even a single source of data. And this is one of the main things that distinguishes it from, for example, LINQ to SQL. In LINQ to SQL, you create an object model, but every entity maps to a single table. And your object model is based on a particular SQL Server database. But in the Entity Framework, you don't have that restriction. So you could have a customer object that maps to the customers table in a database. That customer object could map to both the customers and the customer details table. So maybe you've split up your information on customers in the database between two tables, but your customer entity just has information on the customer. Could be that your customer object maps to the customers table in a SQL Server database, and the customer details come from a web service. So when you build your model, you obviously need to know where the data comes from, but your entity classes don't represent a table in a database, they represent an object. So the Entity Data Model consists of three components. The conceptual layer defines your conceptual model. What are the entities and how are they related? And this is expressed as XML using the Conceptual Schema Definition Language, or CSDL. The storage layer defines the storage model. How is the data stored? And that's expressed in XML using the Storage Schema Definition Language, or SSDL. And then finally, the mapping layer defines the mapping between the storage and the conceptual models. So what entities store what data? And that's expressed using the Mapping Specification Language, or MSL. So your entities are in the conceptual layer. I have a customer entity. I have an order detail entity. They're related. There's a one-to-many relationship between customers and orders, and a one-to-many relationship between orders and order details. Then in the storage layer, I need to know where is this data stored. Well, customers are stored in one or more tables in a database. Orders are stored maybe in the order table in a database. Maybe order details are stored in 3 different tables across 2 different databases. Whatever, all of that's possible. Your storage layer is going to define that. So now you know what your entities are, what information they're going to contain. You know where the data is located. Now you need to map the two of them. So what entities store what data? So in other words, if you look at the customer entity and there are 15 properties in it, where are those 15 properties stored? So in other words, what queries, and that's important to know because LINQ to Entities needs to know what queries am I going to have to send to which data sources in order to get this data. And then if I make any changes to the entity or the instance of that class, what queries am I going to have to write to send that data back to the underlying data store? So the Entity Framework consists of the Entity Data Model and the Entity Client Data Provider. And the job of the Entity Client is to communicate with the various data sources. It's also responsible for translating entity queries into the data source specific queries. So we're going to write LINQ to Entity queries against entities, but something needs to be able to translate those into a query that the data source understands. That's the role of the Entity Client Data Provider. And then when you return data from the data source, it comes back using a data reader. Now, Object Services is another component in the Entity Framework, and this is what enables querying. And there are 2 ways you can query in the Entity Framework. You can use Entity SQL, or you can use LINQ to Entities. We're going to cover LINQ to Entities here. We're not going to look at Entity SQL, but this is a SQL-like language that works with entities. LINQ to entities is a variant of LINQ. Object Services is also responsible for populating the entities with data returned from the queries, and it's also responsible for change tracking, and therefore you can modify data. So once you create an entity data model, you can work with that data. And in your code, you're going to be working with an object context class. And the role of the object context class in your code is to manage the interactions between the data source and your entity classes. So this is how, in your code, you're going to connect to data sources, retrieve information and send changes back, and also track changes. And each of the entity classes are properties of this object context. So in our demo, we're going to create an entity data model called Northwind, and then in code, our object context will be called nwind entities, and then when we want to work with customers, we'll say nwind entities.customers. And if you're familiar with LINQ to SQL, this is familiar because in LINQ to SQL you have a data context, and you'd say nwind data context.customers. Now if you have stored procedures that return result sets, then these become methods of the object context class. So we could call the customers in region stored procedure, which takes as an argument a region, and then that's going to send back the customers in that region. So as I mentioned, an entity class represents an object in your domain. It could be a customer, could be an order, could be a product. And the entity class is going to inherit from the entity object class, which is in system.data.objects.dataClasses. And the entity class contains a property for each piece of information, like company name, order date, unit price. And again, these don't have to be columns in a table. They could be the results of a web service, they could be calculations. You have a lot more flexibility. Each entity class can contain a collection property for related tables. So your customer class will have a property called orders, which is a collection of orders for that customer. And you'll use the generic entity collection class to hold the entities that represent the child side of the relationship. And then in the generated code, that property, so this orders property of the customer class, will use an attribute, and that attribute is EDM Relationship Navigation Property Association. And that identifies the relationship between the child and the parent. Now in the child entity class, there'll be an entity reference class that references the parent. So just as the customer class will have an orders property, which is an entity collection, the order class has a customer property, which is an entity reference, and that will point back to the parent. And in the generated code, that customer property in the order class also uses the EDM Relationship Navigation Property Association attribute. So the first step in using the entity framework in an application is to create the entity data model. And there's really two primary ways that you're going to map your data model to an object model. One is you could use the command line tool. It's called EDMGen. The second is that you can use the Entity Data Model Designer in Visual Studio. So let's go see how to use the Entity Data Model Designer to build an entity data model. Let's create an entity data model. So the first thing I'm going to do is create a new project in Visual Studio. And I'm going to make this an empty project because I'm not going to build a real live application. I just want to create an entity data model. So I'll call this Entity Data Model Demo. And then next, I want to add an item to this project. So I'll add a new item, and I'm going to select ADO.NET Entity Data Model. Now, an important thing to remember about this is that the Entity Framework ships with Visual Studio Service Pack 1. So if you only have Visual Studio 2008, unless you've installed the Entity Framework, one of its CTPs or Community Tech Previews as they're called, then you won't have this template. So I'm going to call this model Northwind, because I'm going to build an entity data model based on the Northwind database. This brings up the Entity Data Model wizard, and I have two choices. I can generate my model from a database, or I can start with an empty model. So we're going to build a fairly simple entity data model from Northwind, so I'll select Generate from Database and click Next. I can now select my data connection, and because I've already connected to Northwind, that connection appears. Of course, if I want to create a new connection, I just click New Connection and use the Connection Properties dialog. Well, let's stick with Northwind for now. Now look at the entity connection string. There's metadata, and the first thing is northwind.csdl. CSDL is the conceptual schema definition language. That's where my conceptual model is going to be defined. Then northwind.ssdl is storage schema definition language. That's what SSDL stands for. That's where the storage model is going to be defined. And then MSL is the mapping specification language. Northwind.msl represents how the conceptual model gets mapped to the schema. So the entity data model consists of those three components, the conceptual layer, the storage layer, and the mapping layer. And they're in XML, though you can store these as actual files. Then the provider, system.data.sql client, and the provider's connection string is the usual connection string we're used to. Then I'm going to save my entity connection settings in app.config under the name Northwind Entities. So now I'll click Next. And now I'm going to choose the database objects that I want to include in the model. So I want customers, I want employees and their territories, I want order details, orders, and territories. And so now I'll click Finish. Now Visual Studio creates the object model and displays the Entity Data Model Designer. Okay. So here's customers and orders. Now we know in the Northwind database there's a one-to-many relationship between customers and orders, and that also needs to be in the entity data model. And it is. Here's an association line between customers and orders. And it's a one-to-many relationship. I can see that by the 0, 1 here and the asterisk there. I can see that it's a one-to-many relationship going from customers to orders. And if I select this and look at the Properties window, let's pin this. There we go. I can see that there's an association named fkey_orders_customers. And I can see that it goes from customers into orders. Okay. Now let's find employees. Here we are. There's an employees table in Northwind that contains a record for each employee. And then there's a territories table, which is basically a lookup table for territories. Now in the Northwind database, let's get this back, there's an employees table and a territories table and an employee territories table. Because there can really be a many-to-many relationship between employees and territories. An employee can be responsible for multiple territories, and each territory can have multiple employees responsible for it. So in the database, there's this intermediary table, employee territories, which just has combinations of the employee ID and territory ID. In the model, there's no employee territory table. There's employees and territories and a many-to-many relationship between them. And then you'll notice in the employees table that there's no territory ID column in here. What there is a navigation property called territories. Also, if we look in the orders table, there's no customer ID property, but there is a customer's navigation property. So the entity data model uses navigation properties to navigate from table to table. Now here there's two navigation properties called employees, employees 1 and employees 2. Employees 1 is a one-to-many, and this is because employees can be managers. So this is actually representing the association between this employee and the people that report to him or her. So I'm going to name this navigation property reports. And then this one here, which can be 0 or 1, represents the manager. So I'll rename this to manager. Okay, so there's my model. Now another way to view this is in the model browser. So here's my Northwind model, and I can look at my entity types: customer, employee, order, order detail, territory. I can expand those to see the individual properties and the association. So customers have orders, an employee has a manager, has reports, has orders, etc. I can also look at the associations, and I can look at the entity sets. So there's a customers set, an employees set, order details, orders, and territories. I can also look at the storage model. So here are the tables that are in the storage model, along with constraints. So I can look at the model itself, I can look at the model browser. The final thing I can do is look at the generated code. Actually, it's not the final thing. The next thing we're going to do is look at the generated code. There'll be one final thing after that. So let's look at the generated code. This is the code that Visual Studio writes to create this entity data model. So we start off at the highest level with the class Northwind Entities, which inherits from system.data.objects.objectContext. And when you query the database using LINQ to entities, the object context connects to the database and will then take results back and populate instances of your entity classes. In the constructor for Northwind Entities is a reference to the connection string, which we've saved in app.config as Northwind Entities. And that was an option in the wizard to do that, so let's go into app.config. Here's Northwind Entities, and here's the connection string. So we saw that in the wizard. So the Northwind Entity class contains a property for each entity. So here's customers, and that's the entity set. And that is a collection of system.data.objects.objectQuery of customer. Object query is a typed query class that can return a collection of objects. What collection will it return? In this case, customer. And so when you reference the customers, for example, in a query, when you say from customer in my object context.customers, then this code is going to call create query to bring back instances of the customer class. Let's go down to the customer class itself. Here it is. So customer inherits from system.data.objects.dataclasses.entityObject. And notice the attributes. There's an attribute for entity type, EDM, which is entity data model entity type, identifying which entity this represents. This can also be serializable using the data contract attribute. So that means that you can send this back and forth using Windows Communication Foundation. There's properties in here for each member, so customer ID, company name, and this code uses on customer ID changing, report property changing, report property changed, on customer ID changed. That's how the object context tracks changes. And this uses an attribute of EDM scalar property attribute. It's the key, it's the primary key, and it can't be null. Now the customer class has an orders property that represents the orders for that customer. Let's go down and see where that is. Here it is. And that is an entity collection of instances of the order class. And it's attributed with EDM relationship navigation property attribute. And this points to the association, FK orders customers. So the customer class has an orders property. The order class is going to have a customer property. And that customer property is going to reference the customer that owns the order. Here it is. Again, that uses EDM relationship navigation property attribute to identify that this property is a navigation property. And we reference the association, and we get the related reference to the instance of the customer class. So you may be asking yourself, why are we looking at all this code? We created an entity data model. Why don't we just go and start querying? Well, there's some good reasons for looking at this. The first part, it's always a good idea to have an understanding, at least at a high level, of what code gets generated when you use a designer or a wizard in Visual Studio. Also, I think that understanding the mechanics of how the entity framework stores information and maintains relationships then makes it easier to write LINQ to entity queries. And it also will make it easier to build data applications that use the entity framework. So now the final thing we want to look at is let's open up this EDMX. Let's close the designer. And then we can open up the EDMX using the XML editor. And no big surprise, this model is stored as XML. Now we said that the entity data model had three components: the conceptual layer, the storage layer, and the mapping layer. Here's the storage model. And this tells us where in the Northwind database the information is stored. So the provider is SQL Client. And here are the entities. Here are the tables and what entity they map to. And then associations. So this is the SSDL, or Storage Schema Definition Language, that describes where the data is stored. The CSDL is the Conceptual Schema Definition Language. That tells us the conceptual layer, or what entities are in here. So here are the entities, the entity type, and the associations. So this XML tells us what our entities are and what properties, along with navigation properties, they contain. And then the final layer is the mapping layer. That uses MSL, or the Mapping Specification Language, and this is going to map entities and the properties they contain to the actual data. So obviously, certainly when you're first starting out, you're going to build your models using the Visual Designer. So obviously, most of the time you build an application with the entity framework, you're going to use the Entity Data Model Designer and build the model the way we did. But you can save that XML out as files, and then you can, in an application, create the model based on those three XML files: the CSDL file, the SSDL, and the MSL. So that's why we looked at that XML. So now you know how to build an entity data model. We have a high-level overview of the code that gets generated and how it's stored in XML. And the next step is to actually write some queries.